AI-powered DNN report for PPC, production planning and control, semiconductor industry. The dashboard video presents an AI-powered DNN report for PPC, semiconductor industry, focusing on WIP analysis and ML predictions for SMC1 to SMC6. The report is attributed to architect, Pradeep K. Suri. The dashboard displays 6 bar charts, each representing different aspects of the semiconductor manufacturing process for 6 specific SMC, semiconductor manufacturing company or site, entities, from SMC1 to SMC6. The legend on the top right indicates the metrics being tracked. Raw material store, INR lakhs. This represents the value of raw materials in storage, in lakhs of Indian rupees. Finished goods store, units. This probably shows the number of finished goods units in storage. Dispatch, units. This metric indicates the number of units dispatched. Client feedback, score. This is a score reflecting client feedback, possibly on a scale. QC pass rate, percent. This represents the percentage of products that passed quality control. WIP raw material, work in progress related to raw materials. WIP production, work in progress related to the production stage. WIP finished goods, work in progress related to finished goods. Let's break down each chart's potential DNN output connection. 1. Raw material store, top left, yellow bars. DNN output connection, a deep neural network, DNN, could be used to predict optimal raw material inventory levels based on historical consumption, production schedules, supplier lead times, and demand forecasts. The values shown in this chart could be either the actual current raw material store values or, more relevant to a DNN report, they could represent predicted raw material requirements or optimal inventory levels generated by the DNN for each SMC. The DNN might optimize costs while ensuring sufficient raw materials to prevent production delays. 2. Finished goods store, top middle, teal bars. DNN output connection, like raw materials, a DNN might predict optimal finished goods inventory levels to meet anticipated customer demand while minimizing holding costs. This chart could display the predicted finished goods inventory for each SMC, helping to avoid overstocking or stockouts. DNN could factor in sales forecasts, seasonality, and distribution network capabilities. 3. Dispatch, middle left, blue bars. DNN output connection, a DNN could be employed for demand forecasting, which directly influences dispatch planning. The values here could represent the predicted dispatch volumes for each SMC, allowing for optimized logistics, resource allocation, example transportation, manpower, and timely delivery. It could also be used to predict delays or bottlenecks in the dispatch process. 4. Client feedback, middle right, magenta/pink bars. DNN output connection, while a DNN might not directly output client feedback scores, it could be used for sentiment analysis on unstructured client feedback data, example reviews, emails, call transcripts, to generate a quantifiable client feedback score. Alternatively, it could be used to predict future client satisfaction based on various operational metrics, example on-time delivery, product quality, issue resolution time. This chart would then visualize these predicted or analyzed scores. 5. QC pass rate, bottom left, green bars. DNN output connection, a DNN could be used for predictive quality control. By analyzing vast amounts of manufacturing data, sensor readings, process parameters, material properties, the DNN could predict the likelihood of defects or failures at various stages. The QC pass rate shown here could be a prediction of the pass rate for each SMC, enabling proactive intervention to improve quality and reduce scrap. It could also identify the root causes of quality issues. 6. WIP by stage, bottom right, orange, teal, pink bars. DNN output connection, this is highly relevant to WIP analysis. A DNN could be used for advanced production scheduling and bottleneck identification. It could predict work in progress, WIP, levels at different stages, raw material, production, finished goods, for each SMC, factoring in machine availability, labor, and order inflow. This prediction helps in optimizing throughput, minimizing idle time, and preventing bottlenecks. The orange, teal, and pink bars represent the predicted WIP levels for raw material, production, and finished goods stages respectively, as indicated by the legend. In summary, for each of these charts, the DNN output would manifest as predictions, optimizations, or insights generated by the AI model. The dashboard visualizes these outputs, enabling stakeholders in the semiconductor industry to make data-driven decisions regarding inventory management, production planning, quality control, and client satisfaction. The AML predictions mentioned in the title specifically point to the predictive capabilities of the DNN being leveraged across these operational areas. Thank you.